Okay, so for number 5, part A asks for acceleration. And since we have the formula force is equal to mass times acceleration, and we can plug force in as 4 and mass in as 0.2 times acceleration. And if we solve that out, you get acceleration is equal to 20 meters per second squared. Now for part B, it's asking for time. So we take the kinematic formula, 2AD is equal to VF squared minus VI squared. And since we know it starts from rest, VI is equal to 0, so that cancels out. And 2 times 20 times the distance of 12 is equal to VF squared. And so VF is equivalent to 21.9 meters per second. And from that, we can use another kinematic formula. VF is equal to VI plus AT. VI is still 0, so it still cancels out. 21.9 is equal to acceleration, which is 20 times t. And 21.9 over 20 is equal to 1.095 seconds. Now I'm going to pass it over to Allison to do part C.
Alright, so for C, we are trying to find the work done by the net force in displacing the object the first 12 meters. And so for a force times displacement graph, the area is equal to work. So it's a square and it's a 4 by 12, so the work done is equal to 48 joules. And part D is asking for the speed of the object, but we already solved that in the previous problem. So the final velocity would be 21.9 meters per second squared. Or no, just meters per second.
Hi, this is Jay and I'll be showing you part E to the question. The question asks for the final speed of the object at displacement x equals 20 meters. To do that first, we need to find the acceleration. So we use the formula F equals ma. To find the force, you take the average between these two, because we know initial velocity at 12, and try and find the final velocity at displacement 20. So you take 4 plus 0 divided by 2, that gives you 2, so there is an average force of 2 newtons acting upon the object. The mass is 0.2 kilograms. When we find A, it gives you 10 meters per second squared. Now we need to find a final velocity. We use this equation because we know all other variables except for the final velocity. Plug in the numbers, 2 times 10 for acceleration, times A for displacement, because from 12 to 20, that's 8, equals the final velocity squared minus 21.9 squared, because that was initial velocity we found from the previous problem at displacement x equals 12. And when you solve for the final velocity, you get 25.29 meters per second. Thank you.